Hi, Math 7a, Exam 1. Number 4. For the graph of the function y equals f of x, find the absolute maximum and the absolute minimum if they exist. Okay, so let's see. This is an interesting graph. It has a point at negative 1, 6. It goes down, it goes up, it goes down. Open circle at 4, 3. And then it's asymptotic at the vertical line, x equals 5. So let's find the absolute max. That would be the highest point on the entire graph. Well, it looks like I would have guessed maybe negative 1, 6, but no, it's not high enough because there's an arrow here indicating very clearly that we have a higher value, infinitely high value. There is no highest value because it continues going upward. Therefore, the answer for the absolute max is none. For absolute min, the lowest point on the entire graph, yes, we do have one. It's located down here at the ordered pair 1, 2. And we're finished. Question number 5, solve the equation by the square root property. The square root property is where you just take plus or minus the square root of both sides. Okay, so we have parenthesis for number 5. We have x plus 3 squared equals 14. Step 1 in solving this equation using the square root property is to isolate the base part that's being squared. So we have parenthesis x plus 3 squared, and on the other side of the equal sign we have 14. We didn't have to move anything over. It was already isolated. Now we're going to get rid of the square by taking plus or minus the square root of both sides. So we do that and we get x plus 3 equals plus or minus the square root of 14. Don't forget, whenever you introduce an even index root to any equation on both sides, you absolutely must include plus or minus. That's for all even index roots, like the second root, the fourth root, the sixth root, etc. Okay, and then finally we have to get x by itself, so we'll subtract this 3 from both sides, and we have our final answer, x equals negative 3 plus or minus the square root of 14. Question number 6, solve the inequality, graph, and express your answer using interval notation. They're asking for 2 different forms of the answer. And problem number 6, the question is, negative 2x minus 7 is less than or equal negative 3x minus 6. That's the problem. I read the question already. Step 1, we're going to simplify, which means we're going to get x alone on the left side. That's what it means to simplify an inequality, get x alone on the left side. So we move the 7 over, the negative 7, by adding it to both sides. And then we move this negative 3x over by adding it to both sides. And we end up with x is less than or equal to 1. That's the simplified version of the inequality, x alone on the left side. Now we draw this in graph form. There's a boxy bracket because there's an equal portion in the inequality, and then the shading and the arrow to the left. And then interval notation, the smallest value shaded in this picture is negative infinity. That always gets around bracket, comma. And the largest value shaded is 1. It actually includes 1 with a boxy bracket, so we put a boxy bracket here for 1. We're going to move on to question number 7. Let me just move this. Number 7, we're going to solve 0 less than or equal to 2x plus 1 over 2 less than 4. It's called a compact inequality because it has 2 inequality signs on one line. It has 3 different regions. The goal here for step 1 is to isolate the x in the middle of the inequality signs. So to get rid of the fractions first, we're going to multiply all 3 regions by 2. 2 times 0, bring down less than or equal to. 2 times 2x plus 1 over 2, and then we get a cancellation, of course, of the 2's. Bring down the less than symbol, 2 times 4. So we have 0 less than or equal to 2x plus 1 less than 8. Next, we're going to get rid of this 1 because we're trying to get x alone in the middle. We're going to subtract 1, let's see, from all 3 regions, and then we're going to divide by 2. I did it all in one step. I should have done it in 2 steps. So if we subtract 1 from all 3 regions and then divide all 3 regions by 2, we get negative 1/2 less than or equal to x less than 7/2. So we have our x alone in the middle. It's simplified. Now we'll actually draw a picture, a graph of this. The smallest value is -1/2. It's included because of the equal portion and the inequality sign. So we get a boxy bracket in our answer. And then we shade all the way up to 7/2, which has no equal portion in the inequality sign. So we use a round bracket and we shade in between. Interval notation, the smallest value shaded is -1/2, and that had a boxy bracket, comma. The largest value shaded is 7/2. It had no boxy bracket. It was not included, so it had a round bracket. Let's scroll down to question number 8. Simplify the expression. Assume all variables are positive when they appear. So number 8 is a tall square root of a rational expression, in other words, a fraction. 12x squared y over 49. First thing we're going to do is use the rule that says we can bust up a fraction with a radical on the top and on the bottom. So this is the square root of the top over the square root of the bottom. But that's equal to, well, the bottom's easy. That's a square root of a perfect square. The square root of 49 is a number whose square equals 49. It's 7. On the top, we're going to try to simplify by factoring down these values that are inside the under the radical and bring all the perfect squares to the front. So 12 was 4 times 3. I left the 4 in the front. I put the 3 in the back. X squared is just x squared. That's a perfect square. Y is not a perfect square. Leave it in the back. Now bust up the multiplication. Square root of 4 times the square root of x squared times the square root of the rest of the stuff that has no more perfect square in it, all over 7. And then evaluate. The square root of 4 is 2. The square root of x squared is x. By the way, it normally would have been the absolute value of x, but they made this assumption that all the variables are positive, so we don't have to use absolute values there. And another thing, we didn't have to worry about doing plus or minus on this problem because we did not introduce this square root symbol. This even index root was already given to us. So here's our final answer, 2x square root of 3y over 7. Moving down to number 9, let's simplify the square root of 36 over the square root of 5. The square root of 36, that's easy. That's just 6 because 6 squared equals 36. The bottom, not so easy. We cannot simplify the bottom. It's called irrational because we can't simplify it. The radical remains. And we're going to go ahead and get rid of the radical in the bottom by multiplying by the square root of 5 over itself. And on the bottom, it's going to get rid of the radical and just give us 5. And the top is the 6 times the square root of 5, and it's all over 5, and we're done.